Hello everyone. Today we're looking at maximize amount after 2 days of conversions, which was question 2 in a weekly contest for 28. So the question reads that we're given a string initial currency, and we're going to start with 1 of whatever the initial currency is that we're given. We're also going to be given 4 arrays. So we're going to have pairs 1 and 2, and these represent conversions that we can make on day 1 and day 2 respectively. So pairs 1 tells us that on the first day, we can make a conversion from start currency to target currency at a rate of rates 1i. Similarly, for pairs 2, this means on day 2, we can convert from start to target at a rate of rate 2i. Also, each target currency can be converted back to its corresponding start at the inverse rate. And we'll talk about what that means in a little bit. So we can perform any number of conversions, including 0, using both of these rates. And we want to find the maximum amount of initial currency that we can get at any point by doing these conversions on both of these days. So looking at the example, we have initial currency is euros, and we have pairs 1 representing conversions we can do on day 1. So we can convert euro to USD at a rate of 2. We can convert USD to yen at a rate of 3. Then on the second day, we can do these conversions. We can do yen to USD at 4, USD to CHF at 5, and CHF to euro at 6. And the maximum that we can get here would be 720. And the way we get that is by the following conversion. So on the first day, we start with our 1 euro. We can convert that to USD to get 2. Then we could take that USD still on the first day, and we can convert it to yen to get 6 yen at the end. Then on the second day, what we would do is we would take that yen, we convert it to USD to get 24 USD, convert those USD to CHF to get 120, and finally convert CHF back to euro to get 720 euros. So when figuring out how to solve this, you may notice that the structure that we're given can be pretty well represented by a graph. So let's kind of draw that out. So let's say we have our day 1 graph. So we might have our euro here, and this will be our starting point for our initial currency. Then we could draw an edge with a value of 2 to USD. And this tells us here that we can take euros and we can convert it to USD at this rate, or we could do 1 over this rate and convert it back, right? And similarly, here we could also convert USD to yen at a rate of either 3 or 1 over 3. So how does this help us? You might be thinking, well, should we actually convert? Maybe it's best to keep our money as euro the first day. Then on the second day, we'll have some sort of opportunity to, convert that euro to something greater that we can get by converting today. So there's a lot of possibilities that we have to try out. And something that we should consider is that maybe we should really look at all our options. So what we could do is we could just start here and we can kind of explore all the portions of our graph and see the max we can get. So what if we were to keep a hash map and we'll say, okay, let's see what the maximum amount of euros I can get for this day is. So I'll start with 1. I'll say I have 1 euro now. Let's record that. So I can convert this back to USD. So let's say we come over here to USD. So at this point, our 1 euro becomes 2. So we could say, well, I have 2 USD in this point. This is the maximum I've seen. Here, we can then go over to the yen, and here I can get 6 yen. So you notice one thing. When I came to USD, I didn't come back here to euros. And why did I not do that? Well, let's think about it. So if I go for my euro, I have 1 euro, and now I can go to USD. And here, I would get 2 USD. Remember, this is at a rate of 2. Now, I could potentially go back. Like, that is a valid transition. I could go from 2 USD back to my euro at a rate of 1 over 2.0, which is 0.5, but then I'm just back where I started, right? So you'll see that there's potential for us to get into infinite loops here because we could convert, but then we potentially could also unconvert it using that inverse rate, and we get into this loop where we go 1 to 2, 2 to 1, 1 to 2. So what we also need to do is we need to keep track of basically if we are seeing a euro and we've seen the value 1, we want to keep track of these states, right? So if we ever get back to this state again, well, no, we've already solved for this problem and we don't want to do it again. So that's going to be kind of our first graph traversal here. We're just going to start and we're going to see what the max we can get is from all of these different traversals. Now that I have this on day 1, what should I do? I already have these maximum values, so how am I using these? Well, now what we can do is we can look at our day 2 graph. So let's think about what this looks like. And I'll scroll down a little bit here. So we can go from JPY here to USD at a rate of 4. We can go from USD to CHF at a rate of 5, and CHF to Euro at a rate of 6. So now I see what my day 2 graph looks like. What I could do is basically I could start a search from each of these points. So let's say that I decided not to convert anything, right? I just kept my euros as they were on the first day. Well, now what I could do is say, well, I'm here, right? I could now try to traverse this graph. Well, I could convert to CHF at a cost of 1/6. So I could try that out and traverse the rest of this, but you'll see I'll never be able to come back to my euro value and have a value greater than this. So we could try it out. We also try out USD. So let's see if we had USD. Well, if we had 2 originally, we can convert it to 10 here and then to 60 here, right? So that's another option we could do. Or we could start with our JPY. We could say we have 6 times 4 times 5 times 6, which gives us that 720. So really what we're going to do is we're going to use these, what we found in day 1, as our start dates for the second day. So essentially, we're going to find those max values and say, at this point on day 2, this is the maximum I could find of each of these different currencies. So let's start there. Let's start with 6 JPY and see if we can get to euros. Start with USD and see if we can get to euros, and then start with euros, and we'll just be in the same place and record those values. Then at the end, what we do is we're just going to return the maximum that we could ever found of euros. So essentially, what we're really doing here is 2 graph traversals. The first day, what we're going to do is that we are going to find the maximum we can get of each currency on that first day, and then we're going to use these values that we found on day 1 as the starting points for day 2 and find the maximum euros that we can achieve. One other thing I want to mention, it might be a Python-specific issue, but one thing I ran into when solving this question is floating point precision. So for example, we might convert 1 to 2, but when we do the inverse, right, when we go from 2 to 1, we might have to divide this value. We might get some large floating point value like this. And over time, our floating point values can get pretty imprecise. And you'll notice that as we're recording values we've seen, we might have something like we have 9, 9, 9, 9, like all these 9s, and we'll have something also like 9, 9, 9, 9, 9, 9. 9, 8, right? So for example, we can get pretty imprecise, and having things like this can lead to memory limit exceeded, right? Because we're just recording these very slight variations when really we just want to kind of cut off at a certain point and say, past a certain amount, we could see that like these are basically the same value. We don't want to have to actually recompute these. So we need to also be careful with how much we're storing in our scene set. So the value that I found is a sweet spot is around 10 elements of precision. So when we have 10 elements past the decimal point, this is a good balance of not only getting us the correct answer, but also making sure that we don't overflow any data structures that we have and making sure that we can safely fit it all within the constraints of the problem. So just note that when we're solving this, I'm going to be rounding my answers to 10 decimal places just to avoid overflowing memory. So the first thing we do here is we're going to set up our graphs. So we're going to have this first scene set, and this will keep track of things that we've seen as we're going through the graph. Then we're going to have our day 1 graph and day 2 graph that we'll use a default dict for. So we're going to iterate through all the pairs. In pairs 1, we're going to just grab the start and the target and the rate. So what we're going to do for this day 1 graph is we're going to insert into the start list the target and the rate. So this is just the straightforward. I want to convert from euro to USD at a rate of 2. But we have to also record the inverse. So we can also go back to the target by, back to the start from the target by doing 1 over that rate. So we have to record both the rate we're given as well as its inverse. Then we do the same thing for day 2. So then this first graph traversal is where we actually find the maximum currency that we can get for each type. So we're going to start with our initial and a value of 1, and we're going to record the max that we have seen so far. So we just pop off of our queue, and then we're going to round that amount, like I said, to 10 decimal places just to avoid overflowing our set data structure. And if we've seen that currency and that amount so far, it's a problem that we've already solved and already explored, and we don't want to do it again, so we just continue past. And then we add it into our set just to record that we've actually done it. Then what we're going to do is we're going to record the maximum of this currency that we've seen so far. So if we've seen a greater value than we've already seen before, then we're going to record that. Then what we're going to do is we're just going to try and convert this currency to every other currency that we can convert to. So then once we finish this traversal, in our day 1 max, we're going to have each currency and the maximum amount that we can get of each one. And this is going to be the basis for our second graph traversal here. So we're basically going to start our queue with each currency, the maximum amount that we could achieve for each of the ones from day 1 max. Then we just do the same thing here. We're going to pop this off. We're going to move past if we've already seen it and just record the maximum values that we've seen of each currency. And then for each currency, convert it to whatever we can try to do. So here at the end, what we're going to return is just the maximum that we have seen of our initial currency, or 1. And we do this because in Python, default dict, it defaults to a value of 0. And we know that if we have a 0 value, that's kind of invalid because we always start with at least 1 of our initial currency. So if we ever have 0, it means we could never find a way to get another value or convert it in a way that gives us more. So we're just going to return 1 here instead. So let's submit and make sure that it works. And it does work. So hopefully this is helpful and it made sense. If you liked the video, please like and subscribe. And thank you for watching.